Welcome everyone to our last Erie Hack Quarterfinal hosted by Midstory in Toledo. We will be hearing from 3 teams today on their ideas to innovate Lake Erie. Each team will have 5 minutes to pitch their idea or innovation, followed by a 3-minute Q&A section from our judges, which is a very short time period. So be sure to keep your answers as concise as possible. And after we hear from all of the teams, the judges will deliberate privately to determine tonight's winners that will be advancing to the semifinals on November 4th. We've got an incredible panel of local judges that have a wide range of expertise, which I will let Sam introduce. But first, I want to thank those that have made Erie Hack possible. Erie Hack is presented by the First Solar Community Giving Fund of the Greater Toledo Community Foundation and the Northeast Ohio Regional Sewer District, and is supported by OHM Advisors, Connecticut, the Community Foundation for Greater Buffalo, Cleveland Metro Parks, and the Gelfand STEM Center. And of course, I want to thank our local Erie Hack champions, including TechTown Detroit, the Blackstone LaunchPad at the University of Buffalo, and Midstory, especially since this has been our first year working together. It has been an incredible experience getting to work with you, Sam. And with that being said, I will let you take it away.
Thanks, Felicia. Well, welcome everyone to Erie Hack Toledo's quarterfinal competition. I'm excited to hear from our 3 teams this afternoon and hope that this competition can really further progress their innovative approaches to solving, some of Lake Erie's biggest problems. Before I open, I'd really like to first thank the Greater Toledo Community Foundation for supporting Toledo's Erie Hack and Midstory's collaboration with the Cleveland Water Alliance, specifically to produce educational content related to water innovation. It's been a wonderful project in collaboration together with CWA. Without the foundation support, this collaboration really would have been impossible. And of course, wanting to thank CWA and the whole team for organizing this entire competition. It has been a sincere pleasure to work with your team, and certainly applaud, their courage to continue Erie Hack during one of the toughest moments of our world's history. I especially want to acknowledge the hard work of Felicia Ontoro for taking the lead in organizing Erie Hack and navigating all the technical challenges that come with running a new virtual platform. So thank you, Felicia, and the CWA team for organizing a memorable virtual competition this year. Really looking forward to many more to come. Well, let me start with sharing my screen and showing a clip from a mini documentary project that we shot a few years back. There.
So there was a major crisis that happened 5 years ago. Do you remember what it was here in Toledo?
No.
No, I don't.
No, economic. Was it a shooting?
Was it the water?
Was it a water crisis?
Water crisis.
Oh!
Ah, yeah.
Jeopardy. The Great Black Swan.
I'm not from it.
Is that the one you can light up on fire?
I feel like I've seen it.
It's a festival.
I don't know much about it.
No.
Yeah, didn't it dry up?
Back in the day, like 1800s or something.
I'm not standing in a swamp now, so it's obviously not that anymore, but it was at one point.
So that was actually a documentary filmed on the 5th anniversary of the Toledo water crisis in 2014, when our city shut down its drinking water for 3 days due to the harmful algal bloom issue in Lake Erie. I show that clip not to assign blame or even to poke fun at our lack of understanding, but to highlight the importance of continued education in our communities so that we are not ignorant and are making the right steps toward protecting our natural resources. Moments like this really humble and remind us of the important work we're doing at Midstory. And we're thankful today that we have found other groups and organizations who share the same goals and values for our region. Like Felicia mentioned, this is the first time Midstory has participated in Erie Hack, and we're excited to continue our on-the-ground efforts together with the CWA. We believe our region's future is tied to how we handle our freshwater resource, and hope we could convince more and more young people to have a renewed perspective on these topics. Our deepest hope is that the implications of Erie Hack can span far beyond the short few months of this competition and can produce long-lasting, effective solutions. When I was listening to CWA's Executive Director, Brian, introduce Erie Hack the other day, I was not surprised at all that we shared similar language when speaking about our region. Our challenges are truly what makes us stronger. They are our opportunities, and as Midstory always says, they are our capital. As a region, we should begin seeing our challenges in a different light. We should examine them with new eyes and invite fresh, bright young people to tackle them. The genesis of Midstory began with this very desire to transform and uplift the post-industrial Midwest landscape, to really progress our narrative through storytelling and research, and through cultivating the next generation of thinkers and innovators who will lead this region onward. I'm honored today to share 3 such leaders today who have truly poured their lives and careers into solving problems and inspiring the next generation. Our judges panel today consists of Dr. Jonathan Bossenbrook, Professor of Ecology and Department Chair of Environmental Sciences at the University of Toledo, whose research continues to lead the field on invasive species and ecosystem management in Lake Erie. Patika Bannister, Commissioner of Plant Operations for the City of Toledo, who has almost 15 years of experience in developing stormwater programs and green infrastructure for the city. And lastly, but definitely not least, Keith Instone, digital experience research analyst who has spearheaded countless tech and innovation collaborations and projects locally, and whom I've had the privilege to work with for many years now. Thank you, judges, for volunteering your time today. And thank you, everyone, for joining us today. Without further ado, let's get this competition started. Felicia?
Thanks, Sam, for those words. And we're gonna go ahead and get started. And starting us off, we have curbing sediment. If the team could please turn your camera on and share your screen at this time, I will put 5 minutes on our timer. And once we're all set, I will cue you to begin your pitch. Awesome. My timer is ready, and I see that you've hit the present button. And so when you start speaking, I will start my timer as well.
Great. Good afternoon. We are Curbing Sediment, Connect to Protect. I am Helena Steiner, and along with Ryan Winston, we will be presenting on behalf of our interdisciplinary team, which includes landscape architects, or PhD students, and civil engineers. Curbing Sediment asks, how can we improve the function of a standard curb, gutter, and apron on a regular city street? Defined by a 6-inch grade change, you may ask, why does a curb need to be improved? Our streets are full of pollutants called first flush toxins. First flush toxins and sediment accumulate on the road, and during storm events are carried via stormwater into the storm drain. Stormwater runoff transports pollutants, including sediment, nutrients from lawn fertilizers, bacteria, pesticides, metal, and petroleum byproducts to Lake Erie, impacting our biggest regional asset. Once in the water, similar to microplastics, they are nearly impossible to remove. Pollutants are ingested by fish, clogging their gills. Pollutants bioaccumulate within aquatic life and impact terrestrial animals and humans who consume these organisms. Although our drinking water is treated, the US EPA notes that 1/3 of public water systems in the US were in violation of federal drinking water quality standards in 2016. You may say, but we have bioswales and green infrastructure to clean our water. This is true, but the EPA cites construction activities, bare soil, erosion, and winter sand application as common sources of sediment in urban runoff, which when routed to bioswales by stormwater, builds up at inlets, clogs soils, and smothers plants. Bioswales also have physical limitations, such as existing mature trees or narrow sidewalks, limiting their application in certain areas. Furthermore, sediment can clog catch basins, which can cause localized flooding. A typical curb and gutter is designed for the conveyance of stormwater only, and what it does not provide is any water quality benefit. Can we challenge conventional design standards like the curb to do more? With widespread use of curbs, small-scale changes have the ability to have regional impacts. If we can design a better curb, one that collects pollutants before they enter Lake Erie, we can improve the health of our watersheds. Regular maintenance of new curb, gutter, and apron designs can be performed by street cleaning machines already in use. We tested 21 alternatives to the standard curb and apron via an iterative design process.
This video shows some of our lab tests from a top view. Simulated stormwater enters the mock road from the right with the curb and apron at the bottom. You'll note the roughness in both the curb and the apron, with sediment trapped in the patterns as the simulated rainfall event continues. These lab scale simulations proved very promising for trapping sediment. These are the curb and apron designs before and after testing. While we have not yet scaled up to the field scale, we believe that a mold or a grinder could be used to create similar roughness in real-world curbs and aprons. Here you can see the performance of the roughness patterns that we tested in the laboratory. We note that the greater the roughness, the better the performance. The best performing designs were able to trap greater than 80% of the sediment in the simulated stormwater runoff, and were able to do so for up to a month of simulated rainfall. These new designs can be used in concert with green infrastructure to reduce clogging, or independently to reduce pollutants discharged from roadways. Curbing sediment's small footprint can be advantageous in areas with mature trees and narrow sidewalks. Custom patterns could be developed for business improvement districts or by municipalities to adapt to specific aesthetic, hydrologic, and/or other physical conditions. Curbing sediment is a feasible alternative to the standard curb and apron design that's been around for more than 100 years. By upgrading the curb, this new infrastructure has the power to transform the standard urban drainage infrastructure. We need step change retrofits to existing infrastructure to make big impacts in Lake Erie's health. Given how ubiquitous roads are in urban areas, within the Lake Erie Basin and beyond, this solution applied at scale could have massive impacts on the health of aquatic ecosystems. Roads crisscross the landscape, forming an ever-expanding network of asphalt. According to the Federal Highway Administration, this network comprises over 4 million miles of roads in the United States alone. They are critical to facilitating movement of people and goods within cities. However, this network also acts as a magnet and superhighway for pollutants. Laboratory results from our testing suggest that modified curbs can collect pollutants from roadways. Small-scale changes in design standards, such as the one that we're presenting today, can have regional and potentially national impacts. So we'll close with thanking you for the sediment, and we will open it up for any questions.
Thank you, Curbing Sediment. If judges could now unmute their mics, turn on their cameras, and start asking their questions.
So hi, this is Keith. Great presentation. Curbs are used for other things though. Are you going to mess it up for other uses, right? Is it going to mess up cars, bikes? I'm not sure, right? So what impact would your change have on other things?
Well, we don't imagine that this would be in every street everywhere. So if there are physical limitations or things that already need to stay in place, that's also possible. But we used tactile paving as our launch point. So that's regularly found in city streets already, and people and vehicles and strollers and wheelchairs move over them already. So the dimensions, although the patterning is different, the dimensions are actually kind of true to things that are already found in our public space.
Great, thank you.
Mhm.
Yeah, thank you for your presentation. The first thing that came to mind is, did you test or look at the variance in amount of water coming in, right? I mean, some of our rainstorms are very small, and then you have the 5 inches that hit a month ago.
Right.
Your
Yeah.
design, how's your design impacted, by
Right. Really, really good question. So the data that we've collected so far on these 21 different designs were triplicate testing done in the lab. So we don't have any field scale data yet under real storm conditions. And I agree that is a shortcoming, and we're actively looking for more funding to develop that piece of this work. The testing that we did in the lab was simulating 1-inch rainfall events at a semi-realistic rainfall intensity for a typical 1-inch rainfall. So I can't speak to anything bigger than that. I think there would be issues in some large events with resuspension, potentially with the force applied by the water as it passes through the gutter. But I certainly think for those water quality events, the system actually worked far better than I expected it to.
We have time for one more question.
Did you look at the impact of salt and snow removal?
Great question. No, we did not consider salt in this particular study, but I think it absolutely is going to have an impact. Certainly freeze thaw conditions in the wintertime as well, with these sort of indentions that you're creating in the pavement through a form or some other method of construction. These are practical real world questions that we're actively looking to answer, but no, we did not look at salt in the laboratory tests.
Yeah, and with snow removal, since the curb patterning doesn't extend very far into the road, most of the snow plows that at least we've looked at, they don't get that close to the curb itself. And oftentimes there's a car parked there, potentially anyways, at least here in Columbus.
Thank you, Curbing Sediment. I will give the judges 1 or 2 more minutes to fill out their criteria, their forms, as we queue our next team up, Water Warriors. And judges, feel free to go ahead and turn off your mics and cameras.
Can you hear me all right?
Yeah,
Right.
But we'll just give another minute or 2.
All right.
All right, John, I think our judges are ready. So you have your camera on, you have your presentation, and when you start speaking, I will start my timer.
Hi, we're water warriors, and we're treating water how we think it should be treated. The problem we're solving is nutrient contamination, namely phosphorus and ammonia, and it's everywhere. This map shows nutrient pollution from ag runoff into the Mississippi River Basin. The pink spots are the cities. The green is all ag runoff. The EPA calls nutrient pollution one of the biggest and most expensive problems. And Lake Erie is only getting worse every year. The EPA designated it as an impaired body of water, which means in regulatory terms that the chemical pollution filtering in through local tributaries is getting much worse. Water Warriors is a small startup that provides solutions to fight nutrient pollution, to absorb it, to get it out of the water so issues like algae blooms and loss of marine life never happen. And then we return it to the land as a nutrient-rich fertilizer. So we develop Poseidon pellets, pellets that are able to absorb phosphorus and ammonia on contact and able to be replaced in the land as a fertilizer. And here's how it works. Water simply flows through our insoluble pellets, and the phosphorus and ammonia stay behind. When the pellets reach capacity, the nutrients are returned to the land as a struvite, slow-release fertilizer. We developed this through a CRADA agreement with the EPA, a cooperative research and development agreement, and Water Warriors holds the patent in our IP. Poseidon is designed for both point and non-point sources, like farms, waterways, stormwater, and wetlands, to industrial and municipal plants. These are the markets we can serve, and the reason why is their pain is the same. The fines and lack of solutions out there are the same, from a wastewater treatment plant to a family fish farm to edge of field runoff to stormwater to even wetland protection. We can make both Poseidon wastewater and Poseidon ag stormwater. It's scalable and we can package it in multiple ways. Poseidon ag and stormwater has a retention time of 17 seconds. These pellets are fast. They need to be. You can't control the flow rate of a storm event. They cost less, but have less capacity. It's a speed and capacity trade-off. Poseidon wastewater has a retention time of 10 minutes. The capacity for these is off the scale. They cost more, but use fewer pellets, and we can calculate them to last 12 months. Here, capacity means more than speed when you control the flow and retention time. And here's an example of that. A sand filter was retrofitted with 500 pounds of pellets at a treatment plant in the UK. It was able to remove anywhere from 50 to 75% of the phosphorus, so they were able to meet their limit. Poseidon stormwater is designed to be used in existing stormwater structures. You simply replace the sand or other media with our Poseidon pellets. Our Poseidon pellets can also be used to treat agricultural runoff and what's known as a P-trap. These are what would be proposed by the USDA. It's essentially a French drain that can use our stormwater media. The P-traps can be connected to tile drainage ditches, anywhere the phosphorus runoff can be diverted into a containment area. There are only 3 parameters to a P-trap: the amount of media needed, and the flow rate and contact time, and the ability to replace and reuse the media. The USDA even developed an app to design them. It calculates everything you need to make a perfect P-trap, from shape to slope to depth to the amount of media. It's really well done. We performed 3 wastewater pilots already that were successful. We saw removal rates at 90% at the highest using our Poseidon pellets in a sand filter. We're working with the USDA and EPA on this technology, and we'd like to show you what our Poseidon pellets can do. Thank you.
Thank you, John. And if the judges could now turn on their cameras, turn on their mics, and start asking their questions.
Well, thank you for the presentation, John. So you talked about the absorption part. What about would farmers use them? would you get the reuse out of the pellets? What's the delivery end on there?
Yeah, you can reuse them. You can just simply put them in a spreader and land apply them. The chemistry only attracts phosphorus and ammonia. So we're not collecting metals or any other contaminants that are in the water. And that's because with our insoluble pellets, when they come into contact with phosphorus and ammonia, they form a crystal called struvite. And that's only formed with the phosphorus and ammonia and the magnesium at a 1:1 molar ratio.
So thanks, John. Yeah, this is Keith. Tell me a little bit more about the intellectual property, without, of course, spilling all the secrets.
Well, you can look it up on Google under patents. Okay. So we developed it with a CRADA agreement with the EPA. And during the current administration at the time, the EPA was being defunded. And so we were able to assign the IP under Water Warriors. So the EPA scientist is the main person with the patent, but it's under Water Warriors IP, intellectual property.
Okay. Thank you.
Sure. And again, it is available online if you really want to get into it.
We still have time for one more question.
Okay.
Is this a product that would need to be removed after a certain period of time? And do you know what that timing is?
So we can calculate that based on 3 different factors. One is the amount of phosphorus that's coming in, right? So if you have 111 milligrams per liter and you're trying to get it down to 1, that's a totally different scenario than if it's at 2 and you're trying to go down to 1. So the amount of phosphorus coming in determines the amount of media that we use and the amount of retention time that you'll need. And then the desired effluent. Where are you trying to get your phosphorus to? Is it 1? Is it 0.2? So with those different levers, we have a simulation model where we calculate it to have an ROI of 1 year. And so at 1 year, you will replace pellets, or we'll replace them for you. And there's a back end to this that after we prove the capability of the phosphorus absorption and ammonia, there's a subscription model that could happen on the back end where these pellets are picked up and then ground up into a fertilizer or just land applied. But there is a model in the phase 2 of this of once those pellets go from being something that's absorbing phosphorus to something that can then dissolve it into the fields.
All right, thank you, John. And as we queue up our next team, Resonance Group, I will give the judges a few more minutes to fill out their rubric. All right, we are now ready for resonance group. If you all will turn on your cameras, unmute your mics, and start sharing your screen. And when you share your screen, be sure to remember to hit the present button. All right, and whenever you're ready, whenever you start speaking, I will start my timer as well.
Are you able to hear me? Can you hear me?
It's a little soft, but yes. Could be my computer.
Is that better?
Quiet.
Okay.
I think it's a little better.
Okay.
Try holding the headphone microphone directly to your mouth.
Yes. Yeah, that should help.
Well, good afternoon. We are members of Resonance Group, a local engineering research and development company here in Toledo, Ohio. And we would like to thank you for the opportunity to present to you today. In 2014, a lot of national attention was given to the algal bloom on Lake Erie, which directly impacted our city of Toledo's drinking water. Though the water crisis of 2014 is known, it is only part of a complex and ongoing issue. One of the most striking elements that is missing from this puzzle is the public awareness of the human impact on Lake Erie. As members of this region, we've been responsible for the health of this ecosystem and the surrounding waterways. This issue is not only preventable, but with intervention, it is reversible. But how? What we are presenting today is an example of how. Our approach is designed to educate and engage citizens to enact environmentally responsible practices toward the solution, using a system that combines biological methods and technology to remediate and monitor local water quality. The community needs to be equipped to become key participants in the solution now. Our core innovation provides a dynamic and interactive platform with a proprietary modular design to educate the community about our region's water issues past and present, such as aging infrastructure, CSOs, and nutrient loading, and how we can strategically drive change together. Our platform also serves as a hub to receive feedback and to connect the community to other partners and initiatives in the region. Our IoT-equipped floating wetland system is designed for use in both fast or slow-moving waterways and demonstrates versatile remediation practices with on-site real-time monitoring. This project provides the community an opportunity to be educated and make preventable changes upstream through daily practices and by participating downstream in remediation efforts, thus combating the issues in both directions. Our tech is in two parts: a proprietary dashboard platform with real-time, publicly accessible data collected from our HEX mod, a customizable modular floating wetland system with built-in data sensors. The key features have 4 components: a dual platform, which is a dynamic web-based platform that will provide education and context around water issues, as well as access to local resources, and will allow for community feedback. A digital interface, on-site interpretive signs that launch our platform from a QR code. A wetland system. Our HEX mod contains native plants proven to reduce nutrient loads and can be implemented in different water levels, flows, waterways, or stormwater runoff areas. Monitoring. Smart, real-time monitoring with customizable sensors. Our goal is to develop long-term partnerships with like-minded community members, including state agencies, local and regional municipalities, businesses, educational institutes, neighborhood associations, and other creative citizens. We see our project as a way to educate the community, to advance our other initiatives in our region and remediate the waterways of the Great Lakes area. At this time, I would like to introduce you to our core team. Our team lead is Terry Brisky. Dr. Zhui Chen is a faculty member in statistical modeling at the University of Toledo, and she is our lead researcher. Mandy Rep is our education and 3D design coordinator, and I am Constance Owens, serving as public outreach coordinator. One of our most precious reasons is to increase public awareness, educate citizens, and to engage individuals as citizen scientists and partners by giving them the tools to enact change both at home and in the water. With our final E.
I believe you cut off. Did you come back in?
Are you here now? I'm here.
We did.
I'm
We
here
had
now.
we had some internet issues here.
So would y'all like to, re-give the last 30 seconds of your spiel? Up to y'all.
Would we be allowed to give the last 30 seconds or last two slides? Wonderful.
Yeah,
Thank you,
it's
Felicia.
Completely fine.
Okay.
The last two.
You can start whenever.
Slide 7. Okay. At this time, I would like to introduce you to our core team. Our team lead is Terry Brisky. Dr. Zhui Chen is a faculty member in statistical modeling at the University of Toledo, and she is our lead researcher. Mandy Rep is our education and 3D design coordinator, and I am Constance Owens, serving as public outreach coordinator. As we have shared today, one of the key components of concern about the ongoing water crisis is the lack of public awareness on the human impact and the human impact on one of our most precious resources. Coupled with this is the need for ongoing water remediation. Our solution is to increase public awareness, educate citizens, and to engage individuals as citizen scientists and partners by giving them the tools to enact change both at home and in the water. We'd like to leave you with our final E, economical benefit. Here are just some of the ways our platform and system can impact our city and the region. Thank you for your time today.
Thank you, Resonance Group. If the judges could now turn on their cameras, unmute their mics, and start asking their questions.
Thank you for your presentation. One of my questions, I guess, especially if you're, there's been floating wetlands used in other places, but you build in some technology. My concern about technology, especially in a place like Toledo, is winter. Have you thought about how the technologies of these hex pods is impacted by ice and snow and that potential damage?
That's something that in our pilot study, that was something that we ourselves were wanting to further investigate. We know that there have been some, we've been in touch with some other people that have done floating wetlands and things like that, and they have talked about different overwintering techniques and things like that. But that's something that we're also looking at in our pilot study to see how the sensors themselves would be able to perform in the temperatures here in Northwest Ohio. So that's something that we're considering ourselves.
The monitoring system that you set up, the dashboard, is that something that could be set up on one of your clients' websites? You could that they could input that data into their website so they can view the impact of the floating wetlands.
Yes, it's through a dynamic platform. So we have an actual on-site educational interactive platform that they walk up to, and they would scan our QR code that's on there that would then launch them to our digital website that has all of the current real-time data that is there. All the data that we would be collecting, because this is an educational demonstration, we would allow that information to be used. So anybody that would want access to our data, we would allow and provide for that. So they would be able to use it on their website if they wanted to.
Great, thank you. So why a hexagon?
Well, we found in some of our research that we have designed it so that it can be interlinked very easily together so that it can make scalability. It can go from something very small into like a small retention pond or into a golf course, or if you want, it can be incredibly large as a floating island, perhaps in the middle of the river. So we like the hexagon just because it gives it a little more stability, a little more shape, and it's interconnecting.
Great, thank you.
All right. Thank you, Resonance Group, for your presentation. The judges will now all turn off their mics and turn off their cameras and head to the deliberation room. And once they finish their discussion, we'll return to the main room to announce who is advancing to semifinals. we'll
Getting
get us
ready.
started. Okay.
Okay, sounds good.
So thank you all for your patience. The judges.
We can't hear you, Felicia. You might need to exit any other application you're using, mic or something.
You can't hear me?
I can hear you. I hear.
Me too.
Okay. Okay. We're just gonna proceed. Thank you all for your patience. The judges
Oh,
have
I hear
made
you.
their-
I'm good.
You're good. The judges have made their way back, and I will go ahead and let Sam take it away to which teams will be advancing.
Great. Thanks, Felicia, and apologies for that technical always with virtual platforms, these things happen. Thanks everybody for joining us at 3:26. We're going to be ending a little bit early, it seems like, but really, really happy with the level of competition today and just seeing the level of innovation and the kind of solutions being provided. So really, really excited to see kind of what you all come up with. Today was a little bit something special, actually. Drum roll, drum roll, drum roll. All three teams will be moving forward to the semifinals. All three pitches will be moving forward to the semifinals. Although we hope that all of them will take up the feedback that you'll be provided by Felicia and the CWA team. There is a lot of opportunity for improvement for you guys to compete at the next level. And we hope that you can really take into account and refine your projects as you move forward, because there are some top-notch teams at the semifinals and you guys want to be representing Toledo in the best way possible. So the teams will be Curbing Sediment, Water Warriors, and Resonance Group will be moving forward to the semifinals. Congratulations to all these teams. We look forward to seeing your refined projects as you move forward and compete at the next level. And just thank you so much for participating this year in this year's competition. We really, are grateful to have people on board to be able to provide innovative solutions at this kind of quality and caliber. So without further ado, I think we'll end tonight or today, and I'll give it back to Felicia to officially end today's session.
Thank you again to all teams for your hard work. And then thank you so much to the judges for volunteering your time to hear these incredible pitches. Wow, all three teams. I think that also goes to show the quality of this quarterfinal. I will be reaching out to all teams with next steps for more information. And to those tuning in on YouTube, we invite you all to check out all these advancing teams at our upcoming semifinals next Thursday at 2 p.m. November 4th, and it will be hosted by TechTown Detroit. You can find us again on YouTube, and thank you